Okay, this video is for Friday, March 14th for Algebra 2. First problem we're going to look at is a graph of y equals 2 raised to the x. And when we looked at this on Wednesday, the first thing we said we wanted to do is make a table. And after you make your table, you want to label it x and y, and you want to make a graph, and we want to plug some points in. The first point we want to try is 0. If I raise 2 to the 0, I get 1. If I plug a 1 in, I come up with 2. 2 gives me 4. 3 gives me 8. If I go in the other direction, negative 1, 2 to the negative 1, negative exponent means to flip it. I come up with 1/2. Negative 2 gives me 1/4. When I plot these points on the graph, 3 is with, let's say 8 right here. So this would be 3, 8. 2 is with 4. 1 is with 2. 0 is with 1. Then my negative ones are negative 1.5. So these just keep going closer and closer. And our graph would look like that. If you notice that the further you go in the negative direction, you never actually hit 0. So we say that there is a horizontal asymptote at 0, and that is a left and right line, so we say it's a y equals 0 line. Okay, the next graph I'm interested in trying is y equals 2 to the x minus 3 plus 4. This tells me there's going to be a shift here left and right, and to figure out what that shift is, we zero this out. This is my up and down shift here, the plus 4. So this is going to be the same graph you just did a second ago, but it's going to be shifted 3 to the right and then 4 units up. So when we make an xy table, if I plug in 0 for x, 2 raised to the 0 minus 3. Well, 0 minus 3 is negative 3, so this is 2 to the negative third. 2 to the negative third is 1/8, and 1/8 plus 4 is 4 and 1/8. If I plug in 1, 2 to the 1 minus 3. 1 minus 3 is negative 2. 2 to the negative 2 is 1/4, and 4 plus a fourth is 4 and 1/4. If we do it squared, 2 minus 3 is negative 1, so this is 2 to the negative 1, which is a half, and 4 plus a half is 4 and 1/2. So you notice that as we keep going here, we're just going to get closer and closer to 4, which is what this means. So the plus 4 means we also shift the asymptote up 4 units. When I go in the other direction, if I plug in negative 1, what do we have here? Negative 1 minus 3 is negative 4. 2 to the negative 4 is 1/16, and 1/16 plus 4 is 4 and 1/16. So that's enough here that we should be able to graph. So what do we have here? At 0, we're at 4 and an eighth. At negative 1, we are at 4 and 1/16. At 1, we're at 4 and a fourth. And at 2, we're at 4 and a half. So the growth is coming, but it's coming slower here now. So let's keep going. If I plug in 3, 3 minus 3 is 0, and 2 to the 0 is 1, and 1 plus 4 is 5. So for 3, we're up to 5, so we're still growing. If we plug in 4, 4 minus 3 is 1, 2 to the 1 is 2, and 2 plus 4 is 6. So now you can start to see it's going to start to take off here. So this is what the graph would look like. The growth is going to start out a little bit slower, but this is the same graph we had. It's just shifted 3 units to the right and then 4 units up. There would be an asymptote going at y equals 4, because we shifted the other one up 4 units from the first problem. Okay, next we're going to look at tables and try to figure out if they are directly varying, inversely varying, or not varying at all. So let's draw two tables here, x and y. Alright, so the first thing we need to know is we need to know the formulas. So for direct variation, our formula is y equals kx, and for inverse variation, our formula is y equals k over x. And then if you remember from class, we said we have to come up with a table test formula, and to do that we solve for k. So if I solve this first one for k, its test formula is going to be y over x is equal to k, meaning every y divided by every x. If it keeps giving me the same number, we would have a direct variation. For inverse variation, its table test formula is y times x equals k, so if every y times every x gives you the same number, it's inverse variation. So in this first table, let's try the division. 20 divided by 1 is 20, 10 divided by 2 is not 20, so we can't do direct variation. The inverse variation, does every y times every x give us the same value? 1 times 20 is 20, 2 times 10 is 20, 4 times 5 is also 20, so this one right here is an inverse variation. Right here for x times y, does 5 times 50, that's 250, 4 times 40, that's not 250, so it's not going to be an inverse variation. Let's try a direct variation, every y divided by every x. 50 divided by 5 is 10, 40 by 4 is 10, 30 by 3 is 10. These all worked, and that would be a direct variation. If neither of these rules worked, then you would have no variation. Okay, if 6 people can complete a project in 20 hours, how long would it take 2 people to complete the same project? So if you have 6 people doing something in 20 hours, if we have less people, Joey, this would require how many hours? Would it be more or would it be less? So I have less people, so therefore my answer should be more than 20. So if I say, let's set up an inverse variation, y equals k over x, we need to let something be y and let something be x. So let's say people is equal to y and time is equal to x. So 6 people for y, we don't know the constant, but they can do this in 20 hours. So if I solve for k by cross multiplying, I'd get 120 is equal to k. And that's not my answer, but I need to know k to figure out my answer. Going back through, y equals k over x. So I know I have 2 people, and I want to know how long it takes. Well, that means I need to solve for x. I know what k is now, though. K is 120. And to solve this, I cross multiply. You can pretend that 2 is 2 over 1. So 2 times x is 2x, and 1 times 120 is 120. So 2x equals 120. Solving this out, x equals 60. So it should take 2 people 60 hours. And that should make sense because what did I start with? I started with 6 people, and I ended up with 2. So how do I get from 6 to 2? I divide by 3. So if I divide my amount of people by 3, it means it should multiply my time by 3. So if I have 3 times less people, it should take 3 times longer to complete the project. So my answer here would be 60 hours. Okay, next up, let's try a subtraction problem from Unit 6. So let's say we have 2x over x plus 1 minus, and we'll say we're subtracting x minus 1 over 3. So, this is a 2 here. We need a common denominator. My common denominator is going to be 3 times x plus 1. So let's give both sides of that. Okay, on the left, what was this missing? This was missing the 3, so we multiply the top by 3, and that gives us 6x. Over here, we were missing an x plus 1. We already had an x minus 1 up top, but we were missing the x plus 1 on the bottom. So we do x plus 1. That should have been a plus down there the whole time. So on the right side here, we need to FOIL this. So what are we subtracting? We're really subtracting the quantity of x squared. Then what are we going to have? Plus 1x minus 1x, which is going to cancel. And then we're just left with minus 1. So this is 6x minus this quantity all over our bottom. And when I subtract this quantity, I distribute this negative symbol. So this is 6x minus x squared minus a negative is a plus. And then we want to rewrite this in descending order. So this should be negative x squared plus 6x plus 1 all over 3 times x plus 1. Okay? Okay, for the next one, we're going to look at a division problem. Let's say we have x squared minus 25 all over x squared minus 1 divided by x squared plus 7x plus 10 over x squared plus 6x plus 5. Okay, so division means we're going to take this second one here and flip it and then turn it into a multiplication. So we need to also factor. So top left corner becomes x plus 5, x minus 5. The bottom becomes x plus 1, x minus 1. On the right, we're going to flip this. So the factored version of this bottom one, I'm going to write up top. So up top here is x plus 5, x plus 1. And this one will come down to the bottom, so this should be x plus 5, x plus 2. We bridge this together and see what can I cancel here now. I see an x plus 5 and an x plus 5, an x plus 1 and an x plus 1. Looks like it leaves me x minus 5 all over x minus 1, x plus 2. And that would be final answer. Okay, for our next one, we're going to go all the way back to Unit 2, and I'm going to tell you to just solve. And this is going to say n squared plus 24 is equal to 11n. So this is a quadratic problem, and we want to solve it. If you remember, there's 5 ways to solve these. So as soon as you see the squared term up there, you want to think, how this is quadratic, which of my 5 ways do I want to use? So the first thing, anytime you solve a quadratic, you want to get everything to the same side and set it equal to 0. So if I do that, I want to subtract my 11n over. So n squared minus 11n plus 24 is equal to 0. And then I'm going to try to factor this. And that gives me n minus 7. That's not it. What's it going to be? How about n minus 8, n minus 3? There we go. And that gives me what? N equals 8, n equals 3. And if you didn't see that, what other ways could you solve this? You could try the quadratic formula, which would be negative b plus or minus the square root of b squared minus 4ac all over 2a. And what would you know here? After you had it set to 0 right there, a would be 1, b would be negative 11, c would be 24, and you would plug those in here. So if we did that, negative b would be a positive 11, plus or minus the square root of b squared would be 121 minus 4 times a times c all over 2a, and a is 1, so that gives us 2. That's 11 plus or minus the square root of 121 minus 4 times 1 times 24 is 96 all over 2. So this is 11 plus or minus the square root of 121 minus 96 is 25 all over 2. So this becomes 11 plus or minus 5 over 2. Well, 11 plus 5 is 16 over 2, and 11 minus 5 is 6 over 2, and here are our answers right here. 16 over 2 is 8, and 6 over 2 is 3. So you could do this one by factoring, or you could do this one by the quadratic formula. Okay, for our next one, we're going to try to solve the absolute value equation. So we're going to say solve, and we're going to try to solve 2 absolute value of x plus 4 minus 3 is equal to 11. First step here is going to be to add the 3. So this is 2 absolute value of x plus 4 is equal to 14. Divide both sides by 2 now. So the absolute value of x plus 4 is equal to 7. Absolute value means we have how many answers? We have 2 answers. So I want to set x plus 4 equal to 7. And I want to set x plus 4 equal to negative 7. And when I solve these, I get x is equal to 3 and x is equal to negative 11. Remember, absolute value means you want to get the absolute value sign by itself and then set to the positive and negative, and you should be coming up with 2 answers. Okay, for our next one, we're going to look at a system of equations. So for a system of equations, the answer is where the 2 lines intersect. If you have 2 lines, you only have one answer. So that's a linear. If you have a quadratic linear and it intersects at 2 places, then you have 2 answers. In this one, you'd only have 1. So in a system of equations, the answer is always where the 2 graphs intersect each other. So if we said we had, let's go over here, let's say we have y equals x squared minus 1, and y minus 2x is equal to 2. The first thing you want to do is solve both lines for y, and in the first one that's already done, so I'm going to rewrite this, y equals x squared minus 1, and in the other line it's going to be y is equal to, we add that 2x over, 2x plus 2. So now these are my 2 equations, so we want to go to our graphing calculator and go to y equals. You want to plug these in, so I know it's hard for you to see here on mine, but go to y equals and plug them both in. So x squared minus 1, and then y2, you're plugging in 2x plus 2, do a zoom 6, and you should see a quadratic shifted 1 unit down, and then you should have a line that's going straight through it, and it intersects it at what appears to be 2 spots. So when I do this, I want to find the intersection points. So I'm going to go to second trace, which pulls up the calculate button, and the 5th one down is intersect. So I hit intersect. It says first curve, just hit enter. Second curve, just hit enter again. Now the important part is the guess. So I'm going to slide my cursor to the bottom left intersection point and hit enter, and you should be getting negative 1 comma 0. And if I do that process again and hit second trace, go to calculate, and I go to number 5, the intersect, again hit enter for first curve, enter for second curve, and for my guess, scroll up to the top right corner and hit enter, and your other intersection point should be at 3 comma 8. So again, the steps we just took, you wanted to solve both lines for y. After you've solved them for y, plug them into your calculator for y1 and y2, and then you want to find the intersection points, and to do that you do second trace calculate and go down to number 5, hit enter for first curve and second curve, and then line up your guess for each of the 2 intersections, and these are your 2 answers. Okay, for the next one we're going to look at vertical, horizontal asymptotes, and if there's any holes in the graph. So let's define each one of these here. A hole. An example of when you would come up with a hole in the graph is if you had, say you had x plus 1 all over x plus 1, x plus 2. Whenever you can cancel a like quantity, you zero it out, and for that example, you have a hole at -1. Okay. For vertical asymptotes, you zero out the bottom. Example, let's say you have 1 over x plus 4. You would have a vertical asymptote at -4. And how do I write the equation for that line? If it's at -4, it's crossing through the x line, so it would be x equals -4. The only exception for the vertical asymptote is if there is a hole that you already found. So let's go back to this first example up here. If you already find a hole, it's no longer eligible to be a vertical asymptote. So in this first example up here, the only hole that would have existed would have been, or the only vertical asymptote, excuse me, that would have existed would have been at -2. So for that one, you'd have a vertical asymptote at -2. So again, once you have crossed off two quantities and designated it as a hole, it's no longer able to be a vertical asymptote. So the only thing you zero out.
Pardon this interruption.
There's the announcements.
This interruption. At this time, please release all students that are receiving awards to the auditorium. For International Academy students that are receiving awards, please release them to the auditorium at this time. All teachers, those students that are part of the International Academy that are receiving an award, please release them to the auditorium at this time. Only those students that are receiving an award.
Okay, got it. Okay, continuing. So again, you would only have a vertical asymptote at -2, and the hole would have been here at -1. How do we find horizontal asymptotes? Horizontal asymptotes, there are 3 scenarios. This is where we compare the degrees, and you can come up with small over big. An example of that would be x over x squared. And if you have small over big, your result is horizontal asymptote being 0. If you have equal over equal, example given, 3x squared over 2x squared, this is where you use the coefficients. Your horizontal would be 3/2. And we could also have big over small, example, 2x squared over x minus 1. This one's the 2. This one is actually a degree of 1. And then this would give us a horizontal asymptote of none. We would not have one. So this is all the different scenarios you can come up with, how to find holes, how to find vertical asymptotes, and how to find horizontal asymptotes. Okay, the next one we're going to look at is a quadratic graph. Say it's 3 up and 2 over. And I want to find all the different parts of it. So I want to find the vertex, the axis, the max min, the domain, the range, the increase, and the decrease. So the vertex would be at 2, 3. The axis of symmetry is always the x coordinate, so x equals 2. The max or the min, in this case, this is the lowest point on the graph, so this is a minimum at where y equals 3, always the y value of the vertex. The domain is all real numbers, or -infinity to infinity. The range, what do I know here? The lowest value is y equals 3, so it has to be bigger than that. So I want to go from 3, I want y to be bigger than 3, and it can go all the way up through infinity. The increase, draw a guy on the line and he starts running. He starts running from -infinity to 2, and from -infinity to 2, my graph is actually going down. So the decrease is from -infinity to x to 2, at which point he's here, and the graph increases as he runs from 2 to infinity. It goes up there. So the increase is from 2 to x to infinity. Okay, our next one is going to be a radical equation. So let's say we have the square root of 2x minus 3, and that is going to be equal to let's say 9. So, to get rid of a square root, you square both sides. So I want to square that and square that. And when you square a square root, you're just left with whatever's underneath. And on the other side, I would have 81. Go ahead and solve. Add 3. So 2x is equal to 84. X is equal to 42. Okay, our last problem is going to be 4x plus 10. All of that raised to the 2/3 is equal to 4. To undo this, we want to raise both sides to the 3/2 power. And when we do that over here, this is power to a power, means we multiply, and that's 6 over 6, which means this goes away, just leaving us 4x plus 10. And on the right, this is power over root, and we do the root first. This is the second root of 4, or the squared root of 4, which is 2, and 2 to the 3rd is 8. Okay, when we solve this now, this is 4x, subtract my 10 over, so that's a -2. X is equal to -2 over 4 when I divide by 4, and -2 over 4 is really -1/2. Okay, that is all the information in the video. Please complete the packet. There is no homework. Have a good weekend.